All right, Priya, let's do some chemistry. The problems that you sent me, a lot of them had to do with concentration. So different ways to measure concentration. So let's go through a couple of them. And first, let me just give you some information, and then we'll go through those problems that you sent me, okay? So concentration in general is how much have you dissolved in something compared to the total solution. Molarity is measured by taking the moles of the solute. The solute is what you're dissolving. That would be like sugar. If you're dissolving sugar in water, moles of the solute divided by the total liters, that's your volume, total liters of the solution. Okay? So the total moles of the solute, let's say you're making sugar water, how much sugar, not in grams, not in mass, but moles, we have to put in moles, and then divided by the total volume in liters of the solution, okay? So that is, in general, what we're doing for concentration. Now there's little added things we can do and little variances to that, but this is basically what we're going to be doing, okay? So keep that in mind. The first question you sent me was, question 22 says 5.36 grams of K3PO4 are dissolved in 500 milliliters of water. What is the concentration in molarity of K plus ions in solution? Okay, so let me write some things down here. This is question number 22. It says we've got 5.36 grams of K3PO4. Okay, so this is your mass. That's your mass, okay? I don't know if I lost you there or not. Hold on, let me plug in. Otherwise it's going to turn off. Okay, so we have question number 22, 5.36 grams of potassium phosphate. That is the total mass, okay? So now we are told that we have a volume of 500 milliliters. Volume is 500 milliliters, okay? What is the concentration and molarity of K plus ions? Notice in here, there's K, okay? So here's what we need to do. Molarity, capital M, is moles over liters. I need to find how many moles this is. This is 5.36 grams of potassium phosphate. I need to change that to moles. How do we do that? We use the molar mass from the periodic table. So you're going to find K, P, and O on the periodic table. All right, when you do, you need the masses. All right, here you go. So all I do is I look on my periodic table and I look for K. It has a molar mass right under the name of 39.1. I'm just going to use 39. So I'm going to find the molar mass, MM, molar mass, 39, but there's 3 of them. So 3 times 39, or 39.1. I've got a P, that's phosphorus, so that is 30.9. It's actually 30.97, so we'll go 31. I just have 1 of those. And then I have 4 oxygens, plus 4 times 16 is oxygen. When you do all of that, you find the molar mass of that compound. So I'm going to do that really quickly. 3 times 39 plus 31 plus 4 times 16. That's 212. So this is 212, and the units are grams for 1 mole. That is the molar mass of K3PO4. 212 grams. Well, you don't have 212. You only have 5.36. That's tiny compared to 212, right? So this is the mass of 1 mole. You have not even close to 1 mole. How many moles do you have? You have to take the 5.36 grams and divide by the molar mass, the 212. Okay? If you take the mass that you're given and divide by the molar mass, you'll get how many moles you have. Just think of it, if this is 1 mole, 212 is 1 mole, you only have 5 grams. So you have a fraction of a mole. You take 5 divided by 212. Okay? So 5.36 divided by 212, and you get 0.025, let's say. 0.025 moles is what you have, okay, of this compound, of that compound right there. Now, inside that compound, look here, it's K3 and then PO4. This is an ionic compound. K and PO4 are being held together because they have opposite charges. There are 3 Ks in there. So when this is put into water, it breaks apart into 3 Ks and a PO4. The K is a negative charge, the PO4 is a negative 3 charge. But the important part here is that you've got 3 Ks inside of there. So when you have 0.025 moles of this compound, you're going to have 3 times that of the K. When it breaks apart, it's going to break apart, and you're going to have 3 Ks for every 1 compound. The number there says K3, so you get 3 times as many Ks as you have the compound. When you put that compound in water, it breaks apart, you get 3 Ks for every 1 compound. So if you've got 1 compound, 1 mole, you'd have 3 moles of K. If you've got 0.025 moles, then you can have 3 times that. So the moles of K plus is going to be 3 times the 0.025. And that's going to be 0.075. That's how many moles you have of the K plus. Now I can put that into my molarity. Okay? And the volume was 500 milliliters. You have to have this in liters. You have to divide by 1,000. Just move the decimal point over 3 places. So that's 0.5 liters. It's half a liter. 500 milliliters is half a liter. 1,000 milliliters is 1 liter. So divide by 0.5. So now I can find my molarity. I'm going to put in my 0.075 divided by a half. Okay? So when you take 0.075 divided by 0.5, you're going to get 0.15. Okay? And this is moles per liter. Hopefully that was one of the answers. Yep. Looks like it maybe is selection A. All right. Hopefully that is correct. 0.15. Now, realize they were asking for the molarity of the K. That's why I had to take the moles of the compound times 3. If they're just asking for the molarity of the entire compound, you would multiply by 3. The entire compound, there are 0.025 moles of that. But when it breaks apart, there's 3 times as many potassium ions in there. Okay? Okay, let's go on to another one here. All right. Let's look at another one here that deals with concentration. So this one says, this is question number 24. All right. Question number 24 says, what is the concentration of Al3 plus in milliequivalents? Yuck. Per liter of a solution made by dissolving 1.45, I assume that's grams, doesn't say, of aluminum chloride. Molar mass is given in 100 milliliters of water. Okay, we shall try this. All right. So basically what you're doing is something very similar. We have to find the moles of the compound. Okay, so we have aluminum chloride. Aluminum chloride. Okay, this again is going to break apart into the aluminum ion and the chloride ion. Notice there are 3 chlorides for every 1 compound, but there's the same number of aluminum as compounds. It's just 1 aluminum for every 1 compound. This number up here is not the number. It's not the number that you have in the compound. It's the charge. So you have 1 aluminum ion for every 1 unit of the compound. Okay? So we have, if I have 1 mole of aluminum chloride, I got 1 mole of the aluminum ions. So that's nice. Okay? So let's figure out how much we have. It says we have 1.45 grams of aluminum chloride, and they give you the molar mass of 133.33. So again, we're going to take the 1.45 grams of this compound, and we're going to divide by its molar mass, which they give you, 133.33 grams per mole. This is the mass of 1 mole. You only got 1.45. You're going to have a tiny amount of moles here. Okay? So you're going to take 1.45. 1.45 divided by 133.33. Okay? And we get 0.01. Okay? We have that many moles. Now, it says, okay, so precisely, I guess it's 0.0109. Okay, because I noticed the answer's there. Okay, moles, that's how many moles we have. All right. Okay, so this is how many we have, and now it says that this is in 100 milliliters. Okay, 100 milliliters. Well, 100 milliliters, but then it says it wants to know per liter. So it wants to know per liter here. Okay, they want to know per liter. So I need to take my 100 milliliters is what's given. I need to change that to liters. So 100 milliliters is equal to, if I move this over 1, 2, 3 places, that is going to be equal to 0.1 liters. It's 1,000 milliliters in a liter. So let's see what happens if we take our number of moles and divide by our volume now. 0.0109 moles and divide by 0.1, and I think that's going to give us then our answer, 0.109 moles per liter. I think that's the answer. The milli equivalence, I'm not exactly sure of that, but it looks, hopefully the answer is B there for you. Okay, if not, let me know. We'll figure it out. Okay, let's do one more on concentration here. I just want to focus on the concentration ones right now, okay? I thought I saw one more. Okay, this is question 23. It says an aqueous solution of MgCl2 has a concentration of 6.23 molar and a density of 1.05 grams per liter. What is this concentration in weight percent? Okay, this is another kind of weird way to look at concentration. Weight percent simply means it is the I think it's the mass, weight percent, so it must be the mass of the solute over the mass of the total solution, and then you multiply it by 100. So you're basically finding out of the entire solution, how much of it is the solute, like the sugar that you dissolve, out of the total mass of the solution. So we need to find those two things. So we have here an aqueous solution, that is concentration, okay, and a density of that. What is the concentration of weight percent in weight percent? Okay, let me think here. So we have a molarity and a density. Let's look at this. Okay, molarity is 6.23. And that is moles per liter. That's what molarity is. It's moles per liter. So if I know how many moles I have of the solute, like sugar, I should be able to find the mass of that. Okay? And they tell me, oh, sorry. They're giving me, they're not giving me the moles, they are giving me the molarity. They're giving me this number, 6.23, capital M. They're giving me this. They're giving me this number right here. Okay? So, and a density of 1.05 grams. Okay. Density is 1.05 grams per milliliter, right? Yes. Okay. Okay, so let's see what we have here. If you look at this, this is the molarity, and this is the density. Let's look at the units. Molarity is moles per liter. Okay? So what does that mean? It means that you have in 1 liter, you have 6.23 moles, because that's what the molarity is. It's 6.23 moles per liter. So we have here 6.23 moles in 1 liter, okay? In 1 liter. Let's figure out what that is in grams. So we have, do they tell us the compound here? Yes, MgCl2. So this is moles, and I want to convert that to mass. Well, MgCl2, I need to find the molar mass from the periodic table. So I look at my periodic table, and Mg is 24.3. 2 CLs, Cl is 34.5, I believe. Okay. Oh, 35.5, sorry, 35.5. Okay. So 2 times 35.5, that's going to be 71, plus the 24, that's going to be 95.3. Okay. 95.3 grams per mole. Well, you've got 6.23 moles, and each mole has a mass of 95.3. So this is where you're going from moles to mass. This is the mass of 1 mole. You've got 6.23 moles, so 6 times that. So you're going to take 6.23 times this 95.3, okay? And you're going to find out what the mass is of your solute. So 6.23 times 95.3, oops, sorry. 6.23 times 95.3, 593.7, 593.7. Okay, that's the mass of our solute. Now, this is the solute. That's the top number here. I want to know what's the mass of the total solution. Well, they told me that the density of the solution is 105 grams per milliliter, right? And a density, concentration, and a density of 105 grams per milliliter. Okay, so this is how many, this is the mass in a liter. So let's find out what would be the mass of the solution if we had a liter. This is not for a liter, this is for a milliliter. So I would take that and multiply this by 1,000, right? If it's 1.05 grams for a milliliter, then it's going to be 1,000 times that for a liter, because there's 1,000 milliliters in a liter. So I need 1.05 grams per milliliter, and then times, there are going to be 1,000 milliliters per liter. So I'm going to multiply by 1,000. That's going to give me 1,050 grams. This is for the entire solution. This is for the solute. This is for the solution. You put them here in this ratio, divide them, and basically it's going to be, you know, close to a half. There's 500 or 600 divided by 1,000. So 593.7 divided by 1,050. And I get 0.565, which is about 56%. Hopefully that's one of the answers here. Let's see here. 56.49. I will take that. 56.49. Okay, that gives me 56 point. I got 56.54, but it's pretty close. Okay, I would go with that. Okay, I'm going to pause right there. I think those were the major concentration problems. Resulting solution, what is it? Oh, let's do one more here. Let's do, it must be number 25 here. Okay, number 25. It says you dissolve 2.63 grams of magnesium in magnesium chloride in 155 milliliters of water. The resulting solution has what equivalent per liter of Mg2 plus ions? Okay, so we have Mg chloride. Okay, magnesium chloride. And again, you'll notice here, this is an ionic compound. When this breaks apart, you get 2 chloride ions for every 1 magnesium ion. So however much you have of the magnesium chloride, that's going to be the same number of moles for the magnesium ion. Okay? So we have here 2.63 grams of magnesium chloride. Let's find out how many moles that is. 2.63. Did we do this one already? I don't know. Magnesium chloride. Magnesium chloride was the 24.3 and the 35. I feel like we did this one. This is 71 and the 24, so it's about 95 there, okay? I'm going to divide by the molar mass of 95. You have to be able to take mass and change it into moles by dividing by the molar mass, okay? So 2.63 divided by 95 about 0.028. 0.028. This is moles. That's how many moles I have. Okay? And then it says that's in 155 milliliters of water. Now, the nice thing is that for every mole of this compound, you have a mole of magnesium. If it had said chloride, you'd double it. You'd have twice as much chloride ions, okay? But I think this is the moles of the magnesium ion, and then you'd have to change the milliliters to liters. So 155 milliliters, 155 milliliters, you have to move this decimal over 3 places. So that's 0.155 liters. So there's your moles, there's your volume, and for molarity, you just take moles divided by volume. Okay? Let's see if we get an answer here. And divide that by 0.155. 0.179. 0.179. Let's see here. Yeah, 0.178. Looks like answer C, hopefully. Okay? Hopefully that's right. Okay. Those are all on concentration. And we will talk more about concentration tomorrow or whenever we need to this weekend. Okay, and then we'll talk about acids and bases, and then we'll talk about everything else as well. But watch this one before, hopefully tomorrow. Okay? All right. Talk to you soon.